not Prism ORM library of JavaScript. If you guys have any questions, we'll be opening up for Q&A towards the end of the session. I will now hand it over to Satyajit. Hope you guys have an amazing session. Satyajit, over to you.
Thank you, Jehan. Hi guys, hope you had a great day at work. So yeah, let me share my screen, and do let me know if you can all see my screen and if it's consistent.
Can see.
Yep,
Okay.
we can see a screen.
Thank you very much.
Yeah, we can see.
Okay, so today it's about Prisma. So Prisma is none other than ORM. It's an object relational mapper. So basically, we have been using Prisma quite often in our projects that we've been working on Paladin, and that's when we decided to share the knowledge that we've gained while we were working on the project and all the knowledge that we learned. So this will be a very introductive and a practical session on Prisma and how to set things up and how to get started. So I'll familiarize with you all what we have learned across, and you all can get started with it right after that. So yeah. So first of all, for those who have not got an idea of what an ORM is, it's better to get a starting understanding of what it is. So ORMs are none other than, in your application logic, there'll be objects that are being specified when you program the application logic. For example, if there's an object that, a typical example would be a candidate or a account object that you are trying to map to the database. So what you'll usually do is write in SQL queries to store the database and store the objects and persist the objects across the application. Usually you don't expect the application itself to be constantly running. So you'll expect it to store it across the database. So that interaction, so the interaction of the application logic objects to the database is made easier by using ORM. So traditionally you'll be using SQL statements and manually writing the SQL statements and having your model patterns to transfer the interactions between the objects and the database. So what the ORM does is it makes it life much easier by abstracting a lot of the stuff. Even at a point, you could even feel that you'll never come across an SQL statement for many weeks while you're using ORM, because it makes things easier while adding in a query builder and also mapping how the fields and how the objects map down to the database. So to understand, there's one key thing in object relational mapping is that it's a relational type. So it's not for, usually it's typically not for non-relational type. So initially it started off as being a relational mapping where the relational databases are mapped with the objects. But of course, going forward, a lot of people have included in NoSQL and MongoDB object ORMs too, which maps it from your application logic data to your databases. So why would you want to use an ORM? So that's the next question that comes up after you understand what an ORM is. First thing is your development gets drastically faster, because if you think about it, having on a daily basis, if you're given a feature set, if you have to constantly write a SQL query and ensure that the types are being matched, or having to generate SQL statements, it would be a tedious task, because you'll have to, if it's a complex SQL statement, you'll have to check if the SQL statement works fine, and then you'll have to create an environment where the testing could be done, and you'll could leave in typos and errors, and there's a manual work involved in it. So it's not about removing SQL from the developer's perspective, but reducing the workload that they might have to interact with it. So it's an ORM is, the purpose of it is not to remove the need for SQL, but rather to simplify it for the developer to get this job done faster. So development becomes drastically faster because the ORM abstracts a lot of the information, while you all could simply, if you have a core understanding of how SQL works, then ORM is life much easier. The next thing is optimized queries. So when we type in SQL queries, when we generate the SQL queries ourselves, we tend to be inefficient in writing the queries, because we will probably follow patterns that we come across or learned, and we might not always know how to optimize it. And even if we did, we would have to either read through a lot of blogs or come across a lot of source code and analyze that and then come across the optimal queries. So ORM is typically a library that is implemented. So if the library already knows how to optimize the query and they know how certain edge cases and functions should be handled. So in those situations, they usually handle it well, and you all would have the ease of not having to optimize queries on top of it. But maybe you could understand it later on how it optimizes the queries, but you all guarantee the work that you're doing are much as optimal as it could be in an automated manner. Then code quality. Code readability becomes drastically higher when you start using ORMs, because the syntax is very much similar to what JavaScript would be. So if you take an application logic where you are typing in SQL statements in your application server, then you're merging in multiple different syntaxes into the same code base. So when you add in the SQL statement, you will have to constantly switch between JavaScript or SQL. And if you're using GraphQL, then you'll probably have to switch back to the GraphQL schema that you're using, or different types of schemas, syntaxes that you'll have to come across and adapt yourself to. So that makes it less readable, as you'll have to, while you're going through your code, you'll have to constantly do the transition and also be able to understand it faster. So the code quality is much less when you have to do it with SQL. And also, usually generated SQL queries are typically you typing the raw text, and if you're doing it without an ORM or without a query builder, so this makes it much more easier to read your code and for people to share and work around with the code too. And sanitizing is basically, it's quite similar to what optimizing and fast development means. Your code becomes much cleaner and much more simpler. So if you all have heard about transactions or prepared statements, so transactions are nothing but maintaining atomicity in a database. So for example, if you all had uh, multiple database calls that have to be wrapped around in one as a whole and not execute partially, so you all might have to write an SQL transaction to execute that. And in that case, if you all had to write in raw SQL, you'd have to start the transaction and in between call the DB calls and then complete that with the in transaction and ensure that the syntax is clean. And if that's a tedious work, as you all might understand, if you'll come across that, you'll have to ensure that all of that syntaxes are added in, and you'll have to also learn what transactions and how to write the proper syntaxes for that. So this is also sanitizing in a way that it makes it simpler to use transactions. We'll come across in the demo section of how you can even type down a Prisma transaction in probably one line of code and add additional syntaxes and how you can make it easier for your life. So yeah, that's basically why you would want to use an ORM. So after we know what an ORM is, we'll probably need to know what types of ORMs there are in the market. So right now we're only focusing on what Node.js covers, all the Node ORMs that are related to Node.js. There's different ORMs for different programming language and frameworks. Like for Java, you can find Hibernate. So likewise, we are only focused on Node.js for the time being, and that's what we are revolving around. So this is a list of ORMs that you will come across. Typically might have come across SQLize and Type ORM. Those are the most popular ones for relational database, and Mongo is for MongoDB databases. And the lower three are usually quite rarely come across. You all eventually, maybe if you're working on niche product and you all just wanted to explore stuff, you all might have come across that. So Prisma is one of the more recent solutions that have come and gaining much more popularity because it's backed by a company rather than others all being open source. And even Prisma is open source, but it's not. It's also being backed by a company, so it does not require funding or a specific developers' commitment to continue the project. Since it's a company, they'll also find ways to market and stabilize their product and how it could constantly develop, develop attention to them. So yeah, and also there's this detailed comparison between the ORMs that I've linked to in the slide. So later on, when I share the slides, you can have a look at that too. It's a bit extensive, so I didn't want to bring that out. It's also done by Prisma, so it could be biased, but again, they've done a good job at comparing all the ORMs and how they market themselves. So that's a good place to start understanding what the ORMs are and how they could be useful. So now we come to the question of what Prisma is. We know that it has an ORM, so what's special about it? So that's what we're going to focus on now. So it's an open source next generation ORM. Open source because you can actually view the code and you can contribute to it if you want to. And there's a development team that's already committing and committed to develop Prisma. So you all can also take part in that as a contributor, and you all can if you all get. So they do also share their actively market their products and constantly update with blogs and new features. So you all can also have a look at the code base, and if you all want to be open source contributor, you can go for that. And by next generation, what we mean is it generates type-safe code generation, so and the schema definition language. So the custom schema definition language, what it basically does is you all define a schema, and that is what is mapped to the database. So like instead, where you all would be writing is structured definition language, that is for SQL, where you'll define the tables and the structure of the tables. So in place of doing that, you all are going to define the schema, and Prisma would take care of the overhead of creating the tables and managing them. So you all just have to manage a schema, and that's all that you have to worry about. The schema also syntax is also pretty straightforward. It's very understandable. So when you come to the point of, so we'll also look into how the schema looks like and how you all can define an alt rate in the practical session. So you'll have an understanding of how the schema works. So type-safe code generation is how Prisma works is it basically has a layer of, it generates the client locally, and your client would be generated based on the models that you'll have. And that would ensure the type safety because the schema definition has fixed types, and it uses TypeScript to generate the code. So you all can ensure on runtime itself that if the fields are matching to what is expected, so the client will handle that. So you all have a much more safer transition from the schema to the database. And ORM, like we talked about what an ORM is. So that's the basic three terms that I was trying to discuss of what Prisma is. Next thing is, where does Prisma come into in the architecture of your application? So usually when your client and server interaction, Prisma doesn't come into play there. It generally comes after where your server communicates with the database. So it's a layer in between your server and the database. We'll also understand in, so Prisma is basically a library that has a set of fixed CLI and fixed set of commands that you can run. And progressively you can do a lot of, they have a lot of components and tools that facilitate their use of the library. And that data access layer is what makes it life easier for us, where we have to just program it with the Prisma's client, because the data access layer is all generated by just one lines of commands. And all after that, what you have to use, we'll just have to focus on the Prisma client, where it's the query builder and the ORM. And we won't have to worry too much about the database on a daily basis, because Prisma takes care of it. So this is where Prisma comes into play in your application architecture. So it's a good place to start off, where you know where Prisma might be applied. So next thing is why Prisma. Again, like I was talking to you, it's been recently gaining more popularity. So I think out of this, the most popular one must be Sequelize, because it's been there for a long time. But even though it was recently, Prisma had recently come in, it is 16,000 GitHub stars, while Sequelize, on the other hand, has 25,000. So it's getting quite close by, and it's constantly gaining popularity because the activity and support provided by Prisma is also very high compared to the others. Because if you all think about type ORM, objection, or any other ORMs, it's usually backed by an individual person. So if the individual person stopped committing to the project, then probably no one else will be able to work around the project, and it'll usually die out after some time. But since Prisma is backed by a company, you all constantly have support that they provide. And the database that so they have a vast set of database that they support, Postgres, MySQL, so those are the list of them. So this is the latest list that I got from the DB. So recently they added in MongoDB too. So it's still in the preview version. Some of the features that, so if it's for MongoDB, Mongoose might be a better solution for that specifically. But again, since Prisma is active developing, you might never know, it might be Mongoose too. And the features that Prisma provide are, like you saw, type-safe database queries. So your queries, you'll have to worry about the type safety. And auto-generated migration. So if you want to change your database, you all can just change the schema definition that we talked about earlier, and that would automatically migrate the data to the database. And your relations API, those are the interaction. So the Prisma client is much intuitive, because it typically uses the SQL terminology from SQL and translate it here. And that is also very intuitive in a way to understand easily. So you all just if you all get started on the project, you all easily adapt to it quickly, because it's very easy to understand. And VS Code plugging to auto completion and for their type function definitions. So that's also there. So you all have the support from VS Code also if you're using VS Code as the IDE. So next thing is we come down to what the components that Prisma has. So like we're talking, these are the 6 major components that we focus on. So the Prisma engine, the schema, the introspection, client, migrate, and studio. So we'll look at each one in detail more in the practical session. That will be much more easy to understand as we relate it with the code. But right now, for a basic understanding, I'll explain to you what Prisma engine is and how the schema comes into play. So Prisma engine is the direct interface to the database. So what it does is, your Prisma client is what you're, so I'll go back a slide. So to explain it, so what the schema does is, so the schema is where we'll define this syntaxes for the models. So for example, if I have a user model and a post model and a comment model, that is, your application logic has users and models, posts and comments. So those will be defined in a schema. And then you run a command that generates the client that enables you all to interact based on those models with the database. So the client is what helps you all create instances of or records for each model. So then comes in the play that the Prisma engine, what it does, it takes the syntaxes generated from the client and patches it and optimizes it before it's run against the database. So your Prisma client, so the Prisma client stays in between. So you all directly interact with the Prisma client, and that would be optimized with the on the query engine before it's sent to the database. So you all don't have to worry about the optimization of the query tool, because this is how the ORM handles the optimization. So for a typical case, Prisma facilitates GraphQL. So a practical session would also be a project that contains GraphQL. So that is built on GraphQL. So if you all have come across the N+1 problem, where when you nest objects within GraphQL, if you all have come across that, you all notice that there's an optimization issue that's called a data loader pattern. So that is specifically solved by Prisma because of the query engine. So when you specify what the functions and data that you want in the Prisma client. Before it's checked against the database, the query engine optimizes it and does all the data pattern stuff. And finally, the SQL is run against the DB. So the query is optimized as possible, because that way you all have the overhead removed from you all having to manually optimize the queries. So that's what the key feature here is. And the query engine is written in Rust. You all don't have to worry about that at all, because it's internally managed. So once you all install the library, it adds in a separate folder to your node modules, and that will have the compiled binaries for the query engine. So you all don't have to worry anything about it. Just have to interact the client, and it will take care of everything else from there onwards. So that's pretty much what the Prisma engine does. So schema, the schema is like I told you guys about the models that you'll define for the application is defined here. So you all have to, there's three specific things that you'll mention in the schema. One is the data source, so where you're connecting your application to. So that is the database. It could be a hosted database or a local database, depending on what you'll choose, and the provider for the database. So in this example, in the screenshot, it's the database URL is loaded from the environment variables, and the provider is Postgres here. So that's how we will define where your database, your Prisma schema is going to connect to. And the generator is how we all are going to generate the client that enables the interactions with your database. So that's a fixed, it's typically fixed only in the case of MongoDB, it differs. So for typical Postgres, MySQL, MS SQL providers, it's pretty much the same. It's a static thing that does not change. So you all don't have to worry about the first two, because the data source is pretty much where your host URL is, which you all would anyway have to define if you are connecting to a database. And the generator client is how you all are generating the client. The models, the data models are what your application logic is about. So how your application, what your application is about, and what models that are there, and what attributes that you all are important to your, and your definitions of that is mentioned here. So these definitions, if you'll notice the ID and the default unique, those are syntaxes that Prisma specifically has, which gets translated to SQL when they're being created for the SDLs and the SQL stuff, while creating the tables related to these models. So it will be a mapping that is handled by Prisma that will understand how to transform the schema into the appropriate tables and database. So next thing that you'll, so we are closer to the practical session, we are coming close to it, because at this point it's much easier to understand those the most of the aspects from the practical session. So the next thing that you might want to understand is what introspection is. So typically ORMs and new libraries come up every single day, maybe day or month. You all get new library released. So usually typically with databases, the problem is that if a company had to adapt, or if a product had to adapt to the new ORM, they'll have to worry about the existing data. That's the biggest problem. So if you just go back one slide, the user model here is very simplistic, just 4 attributes on the user. But you all might have applications that have large number of fields and large number of models that might be much complex to have to refactor them back into Prisma. So what introspection does is, this is a tool that they have developed, knowing that this is a problem that people have having to shift from their own stack. So what it does is, it basically analyzes your database. So you all have to provide the data source and the URLs, right? So based on the connection, what Prisma does it introspects the DB to understand what the schema would be. Because if it can convert your schema into a database structure and SQL statement, so it can also do the reverse engineering for that. So that's what introspection does basically. So so you run a command on the Prisma CLI, and that will introspect your DB and understand what the schema is supposed to look like in Prisma, and generate that for you. So in the future, after that, if you want to update anything, you can interact this Prisma schema. So this removes a lot of the overhead that you all might have to do if you all were to define the whole Prisma schema yourself for an existing application, because you all tend to be, humans tend to err. So to prevent that is what this introspection is. So you all can translate from that and get the Prisma schema. So let's jump to the demo. So the demo is pretty much about the Prisma setup and how to set up Prisma for your project, and how to interact with the Prisma client to connect your DB, and how to make changes to your database, and how you can use Prisma Migrate to alter your database and move on to that. So there's two different cases that we first look at. One is, so initially what we do is, I've already set up a database that with the models. So right now we are focusing on 3 different models called users, posts, and comments. And the database is set up. So initially we'll look at a way of introspecting the DB. That's the common case. You will, if you're using it for a new project, that's fine. That's totally fine too. But usually commonly we'll have to work with a project that's existing that will migrate to. So how we can introspect and go, that's the initial point. And then we can later also look at how we can start from the scratch with Prisma schema itself. So for the case of the demo, stack that we've chosen is GraphQL node in Prisma. Again, I've attached the project repository link to, it's a public repository that I've set up and attached the link to the slides. So we'll dive right into the project and understand how that works. So yeah. So the basic overview of what we're going to look into is these steps. There's 5 steps that I'm trying to cover, and each step has a specific setup. So the Prisma introspection and Prisma setup. So first of all, before this gets started, let's understand the project structure and see if we can get a bit familiar with GraphQL. So don't worry about GraphQL too much here. I've just set it up so that we can interact with the application with much ease. So you don't have to worry about GraphQL even if you're not familiar with that. There's nothing to worry about that. We'll just focus on the Prisma syntax and how it can be used. So that part of it could be extracted for the time being. And so before that, we'll need to understand where Prisma comes into play. So first we'll need to initiate the Prisma client. So once we run this command, okay, sorry, I didn't miss that. So there's this Prisma folder already there. So if you'll notice, the SRC folder is the server's folder directory. So the application logic is defined there. And the Prisma folder is what we locally generate and maintain all Prisma related details in. So if you look at the Prisma schema, I've already added in a schema. So I'll do an easy way by removing that. So like I told you, you'll just have to focus on defining the connection, the schema, and the data source, and how it's interacted. So the data source, if you look at the EMA file, I've mentioned what the DB is. So it's a hosted DB. So you don't have to worry about databases. When you're working with your databases, you can connect the URLs that you all have and define it under the EMA file as database URL and mention it here. Your provider and how it's connected, how it's generated. So the next step that you'll do is you'll run a command called npx prisma introspect. So what this essentially does is it connects to the DB and understands the schema that is defined there and generates the Prisma schema for this. So I've also set up a file called this DB setup. So this is pretty much what the SQL statements are for. So I've already set up the DBs and create the tables for this. So what this is the statement for this. So the Prisma schema, what it does is it introspects the DB and gets this schema. So now that you'll have this, you all are ready to generate the client. So first, like we said, we need the schema first, and then we create the client. That's what is used to interact with the database. So first step is done of introspecting DB. Next step is generating the client. That is npx Prisma Generate. So what this is doing is, based on your syntaxes, it's trying to map it down into what functions are needed to create more instances of this model or update or find or whatever the function that is related to this model, it generates it because it fields are custom. So it won't understand it since it needs to optimize it. It generates the client on your local machine so that if you notice, it will go down into your node models and Prisma. Under that, the Prisma client is what gets generated. So there's some, if you'll notice that the comment, post, these are defined by us. So usually these things get generated on Prisma Generate. And that's what the client is about. So this client enables it so that you can interact with the database. So the next step would be, let's have a look at basic understanding of what the GraphQL methodology about. So right now the basic model is, there's 3 models. One is the users. Let's also set up the Prisma Studio. So Prisma Studio is nothing but just having a look at the database in a viewer. So it's pretty much you all can use Data Grip or any other data management tool, but this makes it easy to view the data that you all have related to Prisma. So it's just a fancy tool that you all can use if you all want, but not necessary. So right now the comments table is empty. I've created a few users for the user table. So if you all look at this, so these are the 3 models that we have: the comment, post, and user. So typically we'll want to create a user, and the users would create posts, and posts will have comments. So that's the basic idea. So I've post to the users, and this is a very minimalistic project, does not focus on security or anything, just for the understanding of Prisma I've set it up. So let's first look at how we can create a user and how Prisma makes life easier for us by using the syntax for that. So the first thing first, in the project directly, you all will have to understand what the GraphQL folder is. It's where, so you all can define it any structure you all want. So how I chose to do is just keep a separate folder for GraphQL, and there's 2 things. So in GraphQL, it's a separate don't worry about it too much, but GraphQL has this thing called queries and mutations. So queries fetching data, so you all can relate that to get in your REST APIs, and mutations are anything that you all have to alter in your database. So your mutation, the definition, by definition, it means changing. So that would mean you all is trying to change something that's in the database. So by creating user, you're creating a record there. So by updating it, it will also mean a mutation. So fetching it is typically retrieving data. So that's all under query. So now we have a model defined here. So this, again, you all don't have to worry about this. This is all specific to GraphQL, nothing related to Prisma. So you all can note that I've set up some endpoints. So let's look at this create user. So to have a look at that, we go into the resolvers, and under that comes the create user. So the fun thing about the GraphQL playground is that you all have this interactive playground that you can use to do your API calls. So for example, to create to call the create mutation, all I have to do is just call it mutation, and under that object call the create user and call the definition for that. So again, these are specific to GraphQL. You all don't have to worry about the syntax. So I'm just trying to get you adapted to it. So usually if it's a mutation, you'll define it at the top of it, at the top level, and then what the mutation is, the name of the mutation, the identifier for it, and the parameters that you pass for the mutation. So let's go into it. I've already done set up the queries for this. And when you'll run this, what happens is, okay, first of all, you need to run the app. So to get an understanding, we are providing the first name, last name, and email when creating a user, and that is in turn creating the user and retrieving it back to us. So this establishes, for example, if I add something called something, and I'm trying to create this record. And if you go back to the database and look at the users table, we'll have record created for Rohan. So now what we're trying to understand is everything is set up. So now we're going to understand the syntax that Prisma does to make this connection as possible. So now we've come to the point where we have to create user mutation. So simply what Prisma does is, you all have this, so to understand how Prisma comes in, into application, we are injecting Prisma. So that's nothing, it's defined here as a, so from a Prisma client, what we do is we instantiate the client. This would reference the generated client locally. So that's what this Prisma client library would do. So we are just trying to get the Prisma client and create an instance of it. So now this Prisma would be something specific to the schema that you all have defined here, and the client that was generated related to that schema. So this is all that you have to do to get the Prisma client ready. And now what we've done is we've injected this. So this is what comes here at the beginning. So that Prisma. So using that, we can access the models in our database that are in the schema that can be used to interact with the database. So a simple, what we're trying to do here is we're trying to check. So I'll write along with it. So it's easy to understand what's happening here. So we are trying to figure out an existing user, and this Prisma returns a promise. So you'll have to wait on that. So this is a asynchronous function. So this is JavaScript related stuff that you probably might have come across. So what Prisma does is first you'll call the Prisma client, and under that, what is the model that you're using? So it's in lowercase syntax. So the model that you're trying to interact with is the user model. And what is the function that we're doing on that model? So we are trying to create it. So it's so first of all, before creating it, what we need to do is we are doing a duplicate check on the email to ensure that there's no colliding, conflicting emails on the database, multiple duplicate emails. So to do that, what we're doing is we're just getting a first record. So it's an intuitive. So this is what Prisma said by intuitive API. So all you have to do is just understand how the syntax works by under the user model. What you're trying to do is get the first where. So this is the syntax for that. Where is simple SQL where matching. Email matches the param email. So what this is doing is Prisma is trying to access the user model and find out where the email matches the provided email. So what we get here is typically essentially the existing user, if there is any, with the email that we provided to create. So then again, we throw in array if it's already existing, and if it doesn't exist, that's where we had to create the user's information. So that's where we come in with the Prisma's user model, and for that we use called the create function. And the syntax is a bit different here. We have to add in the data to mention what are the data that we're trying to create for this specific user. So these models, again, this, if you will have a look at the schema, the user schema has the first name, that's what you did on here. Last name, that's what you have provided here. I'll quickly swap back to the schema. So you'll have an understanding. We have provided the first name, last name, and email. So we collect those three information, and dates we can generate on the service itself. So typically that's also a default timestamp that is being generated on the Prisma client. So this instructs that SQL statements to have a default timestamp. So we don't have to provide it, but we can if you want to. And pretty much that's it for what the user model needs. So with this, a user model can be created. So this is how we got the result. We return back the result that was created, and that's what was returned here. And you all can see how the interaction with that works. So likewise, we can establish this create user and post. That's a nested create. What we have to do is pretty much the same thing, what model we are interacting with. And under that model, what's the function that you're calling? So it's a create. So this is specifically essentially trying to create a user and a post for that user. So what you'll have to do is, if you look at the schema again, but here, so we'll have a look at the schema to understand what this is actually doing. So if you look at the user post, we know what these fields are. These are pretty much straightforward. But what is this comment and post? These are not defined by us on this. We didn't mention, we don't have this on the database anywhere. So if you look at the database, we don't have, okay, there's this field. Okay, this is from Prisma Studio because it understands that comment and post is something related to this model. But typically in a normal database where you have if you use data grip, something like that. So yeah, let's go to the user model. So what essentially would be shown here is you all see first name, last name, email, created date, and updated, but you all don't see this post and comment. So what's that? So where does that come from? So the simple understanding is Prisma understands that if there's a foreign key that is being passed around, so it understands that users create comments. So that way it's a one-to-many relationship. And that's how it understands that a user can create multiple comments. So the field for that is comment, and the data type for that is comment object that is defined here. So that's how it works. So for same thing goes for post. So a user can create multiple posts, and how it interacts with this, it maps it to the model that was already defined here. So a user can be nested with this post model, and this is the function to get that. So now we would ask, like, why use this? Where can this be used? Again, in GraphQL, we have this thing called nesting objects and nested retrieval. So for example, if you're trying to get the first user ID one, it's not just about the user information that we want to collect. In GraphQL, we can do something that's different, that by connecting every nested or related object to the specific user. By that, I mean, when we define we need to get a user, we can get the post related to that user too. So what this function will essentially do is get the user and all the posts related to that. So what it does, it on the background, what GraphQL does, it maps down. So this is directly translated into multiple SQL queries. So that's what it's doing. So typically to get this user, you will have to get since you're providing the ID, we'll just have to do a SQL where clause and match the ID, and we get that user. Now, after we got the user, then what we do is we go through if you're requesting for the posts that are related to that user, we go to the post database, that is post database, and match the posted by IDs. That's the person who's created that. Match it with this. So for example, if it's first ID that I'm requesting for, what GraphQL does, it gets down all the IDs that are related to that, the ones there, and pulls that information out. So that's what this is showing here. So for the first user, ID number one, there's 5 posts that have been created. So if you load that up, these are the 5 posts. So how this maps it down is, gets the user ID, then checks it against the user post table and matches it with the post by ID. That's how it gets it. So this is essentially one query to get the user and another query to get the underlying posts that are related to that user. So what Prisma does is essentially this is something related to GraphQL, what you talked about. So what Prisma can do is it also has this facilitated function. When you go to so this specific thing that I'm talking about, the post, you define that under something called resolvers. So under the user model, we are trying to get the posts under the user. So that's what this is where we define. We have to find. So it doesn't magically get the data related to that post. So we have to define how to get that. So this is where the definition for that is provided. We provide information saying that this user. So if we have a user, the parent means the user's ID. The parent object is the user object. If a user is given, we can get the user's posts by having their ID and matching it against the post database. So now the Prisma's functionally comes into play by just retrieving the first user and calling that simple function that will get all the posts related to that user. So this is where that function makes it easier. This is a very great match with GraphQL because they align in ideology and they have this good mapping. It doesn't mean that you can't use this for relational, but this makes it much easier to use it with GraphQL. And likewise, this is one sort of thing. Likewise, I told you about the data loader pattern where it optimizes the query. Like if you have multiple nests upon nest, you all can even nest this post and connect it with comments. Right now, there's no comments in the database. So if you wanted, you all can nest it with comments too. So this will retrieve all the posts and all the underlying comments under them. So right now there's no comments for this specific post, so that's why it's empty. If there were 5 comments, then the first post would have 5 comments. Likewise, the second post would contain all the posts that are comments that are related to that post. So this nested retrieval of data is what GraphQL facilitates. So that would be made much more easy with Prisma's functionalities, because all you have to do is just call that definition that we've defined the schema and get that out. So that's pretty much us covering what this basic functions does. So update, again, quite simple. We can look at an update function. So for post, what I've done is I've just added in an update function that we've commented out. So basically, if you all have, if you just want to define something, define update an existing post. So what we can do is we can get the existing post for that simple call the Prisma and call the post, because that's the model that we're interested in right now. Find the unique ID related to the post. When you're updating a post, we'll probably provide the ID for that, unless it's a query update. So we provide the ID, and this params we'll probably have to define it from this. And get the post ID. And if this post exists, only then we can do the updates. So if the post does not exist, we do the we get the and throw in it by saying that the post does not exist. And the next thing that we can do is simply update the post. For that, again, call Prisma, call the function, the model that is related to that, update. Pretty straightforward. And so updates usually have to have a condition that you are trying to match against. So if not, it will pretty much mean every single object that is there to be updated. So where we have to match the ID with the params post ID. And what do we update the data to? So the data that we provide for the specific update is, let's change the title to something like this is great, and return the updated post back to the response. So now we've just defined a simple update. What all we're doing is just updating the title. So sorry, okay, this is hard rebelling. We can assume that title is the only thing that we need to update right now. If not, we can actually destructure the whole object and update everything that's provided. So that can also be done. So for the timing, I'll just update title. We can call it update post and the data and provide the should work. And yeah, let's fetch the title too, so we know that updated version is what's. Yeah. So now we can update the second post if we wanted to, and let's first check what the second post contains, and then we can. Let's try to change the fifth post to, again, that to this is great. So let's do that and check again with the DB to see if the fifth one is updated. Yep, that was upgraded. So that's pretty much, so you all might have seen how simple that was to implement a retrieval of data and updating. So likewise, you all can also do something, you all can even run raw SQL statements. You all don't have to completely avoid SQL. If you all needed something to run an SQL statement to, you all can just hit result. I'm just adding the syntax to show how you all can run in queries. So if it's a query that you're trying to run, you all can do a raw query. And this would then in turn, you all can define a statement select all from a post. So this would essentially mean this is simple mechanism to run your raw queries if you want to. Likewise, you all can even execute. If you change it to execute, you all can even do updates. So this would run the query to change the specific table. So update maybe post and set some value and specify the condition. So this is simply a SQL statement that you want to do. And you all can also run transactions. So that's another interesting thing that we talked about. Imagine we needed to do an update, one update, and two, like, let's ignore this part out. Let's say we wanted to do the post update and the comment update. This might not make sense for this specific use case, but imagine we needed to do something like create post and comment transaction. So this would simply be done by Prisma, and there's this function called transaction that takes in a list, and that list would contain the queries that we're trying to run. So this, we could run as many queries as we want here. And this would be like, for example, if it was a situation where like, so these post updates might not make sense, but if you want to look at a bank transaction database where different money is being transferred from one account to the other, we can take it first being a deduction of one user's balance and the other being the addition of the other user's balance. And we can make sure that all of this happens in one go or not. So it doesn't partially happen. So this is what the transaction. So syntax fight is pretty straightforward and not complicated. And if we have a look at it, so you all may think that, okay, since I've already done this stuff, I might be familiar with it first. But if you'll have a look at the documentation, so they very much simply explain how you all can do creates too. So you all can even add in. So if you all wanted to create multiple objects at the same time, you all can even do that a batch create, where you just have to specify the list of objects and all the requests that are needed for that specific object. Likewise, the documentation is very easy to understand and very useful. You all can just, it is very intuitive. So you can see that all the working from full text searches to where clauses and all the specific functionality that you all might expect from SQL to be able to facilitate it here. That's a possibility too. And let's also look at another example of searching through posts. So if you wanted to search through the existing post that we created, I've also added so we just added a post which was having the term grade. So when we search that, whatever the post that is matching the grade term has been retrieved, right? So to do something like that, all you have to do is get the matching post, we find many, and then add in where, and this, like, everything under this, all the items under this end object would be matched with an end clause. And meaning what I'm trying to do is I'm trying to match it against title or content, any of them, and make sure that it's published. So you can usually, when users search, they want to search across posts that are already published. So that's where what would be of interesting to them. So just an example to cover post and then off. So likewise, you all can even select specific statements if you want. You all can even select and say, I only want the is published title and just the title of the post that match this. And this would return only the titles and nothing else. So this is also another advantage of using Prisma. You all can match it to that. So if you'll notice that we are also specifying the fields that we want here. So Prisma has a matching functionality to it by selecting the fields that we need to. So if we needed to do that, we don't have to actually retrieve those data from the database, but we can actually, if we have the fields that we need, we can even add them into this select clause and minimize the data overhead, how much data is being transmitted from the DB to the application. This would also optimize when you scale up your applications. That might be a good place to optimize it. So that's another pretty interesting use case. And that pretty much covers all the Prisma client features. And like, again, some specific use cases that you'll want to look at, you can anytime going through the documentation and understand how to use them. And the next thing that you all will want is, we started with the database and we understood how to generate the schema from an existing database. Now the next thing that we would want to look at is how to generate something from scratch using Prisma. So for that, first let's swap out the DB that we have. that we're using right now, because that one already has a database. And if you try to migrate to that, so there's a problem with migrating data that's already existing. So if you want to do that, it's a bit tricky, because when you're migrating to existing databases that exist with value, like with records, when you change columns or create new columns, you'll have to handle how you'll make the changes, because if it's a column name change or if it's column name dropped out, it'll essentially drop out that column in the database. So you'll have to be a bit careful on that. So how I usually prefer to be safe, we do the introspection method. So what we do is, for example, if we are updating the database, we update it through SQL statements, and which is pretty rare. And if we do that, when we update the database, we introspect the database back again and make the same changes across all our staging servers, all the servers that we have. And that will make it easier. To make life easy, you can also use the Prisma Migrate. I'll just run you through what the commands for that is. I've also added an extra schema, but added an extra model called membership. So that's pretty much what I just wanted to find another model that matches with the existing ones. So we could think of users having membership IDs. So what essentially is done here is we can copy this, and first of all, to define this, we'll probably have to manually add in the syntax. For example, if I'm creating this, what I'll probably do is, let's assume this. Yeah, we can also use the Prisma format function. Wait, that would update that. So Prisma format, what it does is, if you all are trying to define a new model like this, if you'll miss out to specify the relationships, you all don't have to worry about that. So you all can just specify if user is, how user is referencing the other model. That will typically what you all do. And even if you all miss out the specifications, you all can use the Prisma format. That will take care of generating the nested models. So you all don't have to worry about these things. All you have to worry about is the fields that you're interested in and the data types for them. And if it's specific to the DB, so string is a very abstract term in terms of database. So strings in database, you have raw, char, medium text, long text, and there's a variety of types of data fields that are there. So this is specific to the data provider that you'll have. The syntax changes according to the provider that you'll use. So for this is basically MySQL syntax that you'll use. So for Postgres, it might be a bit different. So varying on that, you can even define a typical string value, and it will choose the default values for that. So ideally, that's not what you would want to do. You'll probably want to specify the type of field that you're specifically looking for. If not, you'll have to, while going through the application, you might face errors where the field either does not match the data that it's being provided. Either it's too short or too long, or it's unnecessarily taking too much space. So likewise, once you'll define the schema, and a tool that assists that definition is also the Prisma format, you all can keep it spacing issues. Everything will be sorted out by Prisma. They just make it as easy to read as possible. So you all just have to define the syntaxes properly, and any errors with format, you'll mostly can fix it. And once this is done and added to the schema.prisma, then you can run the migration function. What this will do is essentially migrate your database to, it will create a migration script. So what that means is it can identify where how to get to your current application from the schema that you've provided. So that's what it initially does. So if you run this, what this would essentially do is it will create a folder under Prisma called migrations. So that is essentially how Prisma relates it and matches it against from the starting point of the DB and what changes it. Yeah, that's fine. This is a database that we should produce data. So this is a problem that I was talking about. If you have existing data, that's going to be a bit tricky because you'll have to handle that use cases also. So right now, since it's dummy data, so it's fine. So if you look at that, init is the function name that we gave to this specific table. And if you look at migration script, so it's converting the schema that we provided into the SQL statements related to that and creating the appropriate tables and fields accordingly. So now let's say we added a field, suddenly we think of it user first name and last name, and we probably need to collect their country, something like that. And let's just copy paste the same. We probably think that country does not exceed the 400 characters. And now we've decided to edit this. So first thing to save, just to be safe, we just check if the Prisma format changes anything. There's nothing, fine. We can add another migration. So, and define what the name of the migration could be. So we can, initially we can call it init, and we can now call this add country to user. And if you do this, what this would essentially mean is to pick that up into the migration script and collect what the new migration is from the previous migration. So you all should not alter this migration folder, leave it as it is. If you're working with Prisma Migrate, do not go to alter this, because this is this is how it understands how to sync your database to the current version from how it was right at the beginning. So if you look at this new migration script, all it contains is adding the field to the table. So likewise, you all can even add renames. You can do much of things. So one of the things that we came across while we were working on is most of the fields in snake case, we were trying to shift it to camel case in the database itself. So while we were trying to do that, when we we initially thought it was just a matter of changing all the field names. So what we did was we tried doing this to all the fields and did the change and tested it. So what it essentially did was, to confirm it, I checked what the migration script was. It was actually dropping the existing columns and creating new columns. So that's the tricky case where you want to avoid, because it essentially means dropping out all the existing data and creating new one. That's similar to the error that we faced here. If you want to reset your database and all data will be lost, this is the question that it rises up. So if you have a data existing, probably you need to figure out, you can also validate these SQL scripts and update this, not the folder structure, you all don't delete them, but you all can also customize the way you'll update the DB. So if it's something, what is being picked up by Prisma is not accurate to what you're expecting, you all can customize this too. So those, you all can refer to the documentation for that and get an understanding of how you all can alter that. So that's pretty much it about Prisma's migrate functionality too. And yeah, so it covers up the practical session. And yeah, let's get back to the slides. And so we did also cover up the Prisma Studio. So as for learning resources, what you all might want to look at is ideally the Prisma documentation is more than sufficient. And because as far as I come across, I didn't have the need to go check other documentations or other blogs. That is pretty much plenty for what was necessary. And specific certain edge cases, like there was a situation where one of our developers did face a specific issue. So those were probably needed to be managed separately because of the stack that we used. So likewise, ideal documentations and learning resources are the Prisma documentation, the YouTube channel that they have, and sample projects using Prisma. So as a understanding of what the projects they might have. So they have a variety. So right now, if you all found that GraphQL was not your stack that you're using, you all have REST APIs, Next.js, whatever your combination is, they probably might have covered it. And they have a lot of the famous projects with GraphQL and Prisma integrated with it. So all the Prisma examples that they have it. So the best thing that I would suggest to read the code and understand it and get started. That way you all have a much more familiarity with stuff you all build. So these are some references that you all could probably have a look at. And yeah, it's time for question and answers. So I would appreciate if you have any questions and we can try to discuss and sort it out if I do have answers to it. So yeah, anyone have any questions? Oh, I was also thinking of intermittently checking if I lost connection and dropped out because everyone's silent. So I'm hoping that it is not the case.
No, that wasn't the case. Satyajit, can you hear me?
Yeah, yeah.
So when you're actually committing the code to the repo, which files do you usually ignore and which files do you add?
Yeah, so ideally speaking, the Prisma whole folder, you all don't have to avoid that. You all can include that. So all of them are required because the migration script, if you make changes to it, you all would need to track them. So in specific cases that we used, we didn't go with migrations because that was, like I said, there are some complications in that. It was easier for us to introspect the DB rather than having to do the migration script here. But ideally, all the whole Prisma folder needs to be committed. But for the Prisma client that is being generated, for example, if you are using CI/CD pipeline, in AWS, for example, what we do is we use code build. So on the code build, you all might have noticed that I ran a command called npx Prisma Generate. So when we start off, we have to generate the client every time the server rebuilds. And that is so the schema is necessary for that. So this folder and this function additionally needs to be, this command actually needs to be run before the server actually starts up. If not, it'll throw an error saying that Prisma client was not found.
So that command's getting run with the build command, right?
Yeah, along with the build command. Yeah.
Okay.
NPM, if it's an npm one start, along with that, you'll have to run the npm Prisma Generate. Yeah.
Got it. Thank you.
Okay. Yeah, that was actually a good question because I missed to mention that out. So likewise, if you all have any other questions, anyone else? Yeah, while you'll think of questions, and I can just run you through Prisma's documentation. And wait. Just an overview of the documentation, how they manage stuff. So you all would want to check into their blogs, because that's an interesting point where they update the recent releases and everything that they're working on recently. So they even had, I came across this other project called IOPool, how they migrated from their product and added Prisma into that within 6 months, how they migrated that. So there's interesting stuff that you all might have to want to look at in the Prisma blogs. So this is an additional thing that you all can. And also, if you all are interested, you all could probably apply to the Prisma Ambassador program. So that's something Prisma also does to grow their community. So what this is essentially is you all contribute content, and they'll give you all a title that acknowledges your commitments and to learning and expanding the growth of Prisma itself. So Ambassador is, if you'll create one piece of content, and every quarter of a year you all can contribute to the community and also have recognition that you all, this is somewhat related to certificates that tools provide. For example, if you're in Elasticsearch or AWS, an acknowledgement that you know it is by completing the certification. Likewise, if you're an active developer, you all could also, you all don't have to contribute to the source code itself, but at least sharing knowledge about it and contributing to the Prisma community itself is also an acknowledgement that they receive, that they accept. So there's two types of programs, the Ambassador and Ambassador Champion, which you all could, if you're interested, you all could, when you're at it, if you're using Prisma, you all could think about applying for that. It's a good acknowledgement. Might be interesting to have increased recognition too. Yeah. So I guess I gave you all time for questions. So anything else? Anyone else?
Yeah. Also, Satyajit, so when you're generating the client, is the client OS dependent?
Actually, not. I've not actually checked across that, but as far as I've come and checked, I've not had any issues with the client that was generated. So it's typically not OS dependent. But again, if you all have restrictions on how you all can execute the command to generate the client, that's a problem, because like one of the developers that we had an issue running this command that injects into the Prisma Node modules. So if you all have restrictions on folder accesses or permissions, that's going to be a problem where you all won't be able to create the folder. So that command, which essentially the user that runs it. So that might be an issue. But I myself have not tried Prisma with other OSs, so might not be this person to answer that. Yeah. So yeah, as far as I've come across, I don't think there's an OS dependence issue.
Okay, bro. Thank you.
You're welcome. So anyone else? So yeah, if I assume that silence is no more questions, and yeah, at least I would love to have some feedback on how this presentation was. If you all found it, I've got a typical feedback saying that I'm too fast at presenting, so that's something that I'm working on eventually and trying to slow down a bit. So other than that, or anything, even that, if that's the case, well, could provide any feedbacks of how the presentation could be structured better? If you do have any feedback, so I'm open to it and appreciate any feedback. So yeah, anyone has any feedbacks here?
I think you covered like most of the Prisma thing, and it was very helpful.
Would you, do you all have anything in mind that probably?
Really good job, Satyajit.
Awesome. No, thank you. So yeah,
Yeah, that's a really good job.
Satyajit, so I have a question.
Yeah, sure.
Yeah. So I have a question, Satyajit. So there are scenarios people choose raw SQL over ORM, right? So what made you choose ORM, not raw SQL?
Okay, so the basic problem being that it's SQL competencies required skill that a software should have. That's not an opinion that I would like to change. But if you all took into account of how simple and easy this code is to understand, that is what makes it Prisma consistent across the syntax. So if you look at this, all of this is JavaScript syntax. There's no SQL here. There's no additional code that you'll have to transition within syntax. So it's pretty much, so you all know that objects have functions and models, and under that you all can easily access this. So everything is pretty much JavaScript syntax and easy to read too. So you all would, if you all are familiar with the stack, once you all have gone past the learning stage and you'll have the familiarity, it will make life much easier. Because if not, imagine the same situation if you had to translate this. Let's take this for example, the where clause where we have to translate this. If you were to write the SQL statements ourselves, we probably have to make sure that all the end clauses are correctly matched and how it's been nested. So that would be, so the one way to do that would be essentially so you all would have to write down your SQL syntax here. So which would mean if we don't structure it well, and if we miss out to mention something like if it's a where clause, and the first condition being title contains, so this again comes into title like, and you all would have to probably match it with the specific object that you are trying to match it against. So then again, search query. So already it's a bit of, it gets clumsy with the first line itself. So you all would have to match it against the all instances of this OR clause, and then surround it with brackets appropriately, and then after that apply the AND clause on top of that. So that's another set of clauses. So this is very hard to test and run against. So if you make a mistake here, you'll essentially run the wrong queries against the DB. So to do that, first what you'll do, you probably have to run this query against your DB and check if the syntax of the query looks fine, and then come back here and implement the SQL query here. So this is using Prisma, you all can run this too. But if you all were to use a direct model that establishes a connection with your provider that you'll have, and again, think about a case where you all would want to migrate from one DB to another. If you change the SQL syntax, you'll probably have to change the whole code base where you apply the syntax specific to that provider. So now in this game, in the case of Prisma, all you have to do is just change schema and provider. That's essentially that all you have to do. If you just change it to Postgres SQL, if I'm not wrong, that's the spelling right. All you have to do is change this also, because that's these fields are specific to MySQL, and all you have to do is just change this, not instances of all the SQL queries. And that's essentially it that you'll have to worry about, not the SQL itself. So the refactoring makes it life easier if you use an ORM. So this is one of the preferences that I have of using Prisma, but doesn't mean that Prisma is the best ORM that you could find. Probably for the use case that you're trying to cover might be a better alternative, or something else that you could work on. But typically having not using SQL statements might be a case like for small scale applications, it might be ideal to use an ORM where you can actively develop faster and ship features faster. Again, it's not like ORMs don't have drawbacks. There are situations where ORMs might be actually less efficient, as in it takes some latency issues, and situations where high frequency calls and low latency calls are the case. You'll probably want to move away from ORMs. So y'all could also check out blogs that explain the drawbacks of ORMs. I did come across that and didn't want to come too much in depth. It will take time. So what are the drawbacks of it? Y'all could have a go through it. There's a Stack Overflow answer explaining it clearly. So I'll try to link that to y'all along with this. It explains what the drawbacks that could be that usually people face when they try to focus on that. But that again, it comes at a point where your application is scaled to the extent where there's high frequency and low latency called are the top priority. But again, if it's projects that you're starting off with, using an ORM makes life much easier to ship features. And then eventually you all could refactor it and move out of ORMs if it's the case that the need calls for it. So I hope I answered the question.
Thanks.
Okay. Are there any other questions or feedback?
Sajid, I think you covered almost
Yeah, I think, we can wrap
everything. Yeah.
Yeah, I think that's it. So thank you guys for having me, and hope you all found this session useful. And again, the repository is linked in the slides. I'll also attach the reference materials that I came across while doing this and send it across the link to. So yeah, hope you all the session.
Thanks a lot, everyone. Thanks a lot, everyone, for joining, and thanks a lot, Satyajit, for the informative session. And it was really valuable. And yeah, everyone, let's meet up with our next Tech Talk next Friday. And hope you guys join that too. And if you guys have any questions, we will be opening up a tech forum very soon in Slack. You guys can shoot questions on this topic or whatever you want on that. And you can contact Satyajit if you have any further questions on the session as well. And thanks a lot for joining. And this is actually a good start for the series. So thanks everyone. Thanks Rochelle for the organizing for organizing the session. And thanks. So thank you. So then let's wind up for today. And good evening, everyone.
Good evening. Bye,
Thank you, guys.
See you guys. Bye. Have a great
Sure.
weekend.